All right, guys, we're going to go over the notes from number 6 here on slopes of linear equations. So definition of slope, all right? You'll hear a lot of students say rise over run for definition of slope, which is totally acceptable. This is really looking at the change in your y values over the change in your x values. It's another way you'll hear me describe it. All right, I'm hoping you guys feel comfortable with slope since you worked on so much slope in Algebra 1. Some methods we can use to determine slope. I mean, if you're given a graph, you can just count. All right, this idea of rise over run. We'll be doing that a lot. We can use the slope formula. All right, that's always acceptable. All right, and then sometimes you'll just recognize special ones. So the idea will be like, if you have a horizontal or a vertical line, this is where you should hopefully, we're going to look at a few examples like these in these notes in this video. But the idea is that if you notice that the line is horizontal or vertical, then you should immediately know the slope without having to like calculate anything. Okay, a positive slope. All right, so we'll do a positive slope here. We'll do this one as a positive slope. All right, you can always think like going from like the bottom left to the top right. Negative slope is the other way. All right, so it'd be top left to bottom right. Something like this. I made them pretty basic slopes there, but I think they're both 1 and -1. Zero slope. All right, so zero slope. This is going to be a horizontal lines. Horizontal lines have zero slope. So we'll go and put a horizontal line here, and y equals 2. So whenever you see a horizontal line, that line has zero slope. And then for vertical lines, they have undefined slope. So here's x equals 3, and this would be undefined slope. So you just want to go ahead and try to memorize that. So horizontal lines have zero slope, and vertical lines have undefined slope. How do we find slope from 2 points? Most students are going to use the slope formula, all right, which is the change in your y values over the change in your x values. All right, and then how do you find a slope from a graph? Right, so you're going to find 2 points on the graph, and you're going to count how far up and over. Now, I always go up, and then I either go left or right, depending on if it's a positive or negative slope. But feel free to go down. Just be careful if you're going down in the y direction, that is a negative. So then you have to always think of it as like a fraction, like over here. So I'll show you a couple examples of where you end up actually going down, and left is actually going to be a positive. A negative divided by a negative becomes a positive slope. Okay, let's find some slopes based on some information, starting with lines. So like I said, first you just want to find 2 points. And I'm going to just use, they have a point that is the y-intercept, and they have a point here, and I'll go and label them. This is 0, -2, and this is 1, 1. So the way I would do this is I'm going to count how many units am I going up. So 1, 2, 3 units up. How many units am I going to the right? 1 unit. So your slope is going to be rise, which was 3, over run, which was 1. So the slope is 3. Notice I did positives for both of these. Going up is positive, going right is positive. Okay, let's do this one. Immediately you should recognize, and this is actually y equals 2, the one we just did, right? Horizontal lines have zero slope. So this one is 0. All right, when they give you ordered pairs, go ahead and just use the slope formula. That's the most basic way to do this. So we're going to find the change in our y's over the change in our x's. All right, and I always use the second one listed as my second point. It really doesn't matter as long as you have, like, if you choose one y value to start with, make sure you kind of link up the x value to start with as well. All right, it should be the same one. So I'm going to start with this -11. So -11 minus 7. So by starting with that -11, when I do the denominator, I need to start with the one that came with the -11, that 10. So I'm going to do over 10 minus -8. So that's the change in your y over the change in your x's. Doing a -11 minus 7 is -18. 10 minus a -8 is actually 10 plus 8, which is 18. Divide that and you get -1. Okay, this next one. We're going to use the slope formula, but you might recognize what's happening already. So the change in our y over the change in our x. So I'm going to do -6 minus -6. That's the change in our y's. Over 3 minus 1. So -6 minus -6 is actually 0. And 3 minus 1 is 2. So this has 0 slope. And you should hopefully recognize that since both y values are the same, this is a horizontal line, y equals -6. And as we discussed earlier, whenever you have a horizontal line, that line has 0 slope. Okay, a table. Choose any ordered pairs you like. I always choose the first two, but it really doesn't matter. So I'm going to choose these two. Just make sure you know that the ordered pairs are 2, 0, and 2, 1. You might recognize what's happening here as well. So I'm going to do the change in my y's, so 1 minus 0, over the change in my x's, 2 minus 2. And you get 1 over 0. Now this should be a huge red flag whenever you see a 0 in the denominator. You cannot divide by 0, so this slope is undefined. All right? And if you recognize, if I kept going in these x values, you might have recognized that all the x values are 2. So this is the line x equals 2. That's a vertical line, which means it has undefined slope. Okay, let's do letter D. Again, I'm just going to use the first two, but feel free to choose any two that you want, first and last. The middle two, doesn't matter. So the change in my y's is 6 minus -5 over the change in my x's, which is 4 minus 2. 6 minus a -5 is really addition. You get 11. 4 minus 2 is 2. And that does not reduce, so I'm going to leave it as 11 over 2. Feel free to write it as a decimal or a mixed number if you'd like. Okay, next one. We're going to determine the value of r so that the line that passes through each pair of points has this given slope. So essentially, instead of on the last problems where we had to find the slope given those 2 points, we now know the slope and we need to figure out the missing value for r. So I'm going to do 3/4 is equal to the change in my y's, so 5 minus 2, over the change in my x's, r minus -3. So that's 3/4 equals 3 over r plus 3. All right, so you can go ahead and use cross products here because these are, this is a proportion. So I'm going to multiply the 4 times the 3, and I'll multiply this 3 times r plus 3, and write 3 times r plus 3 equals 3 times 4. All right, so that's going to be 3r plus 9 equals 12. Move the 9 over, and you get 3. R equals 1. Now, what you might have noticed, you might have been like yelling at the TV or at your phone or whatever screen you're watching this on, is that if I try to erase these highlights, you might have noticed that these 3's are the same in the numerator. So since those are the same, what I could have actually done is understood then that this denominator has to be the same as that one. So r has to be 1 to get that 4. So 1 plus 3 is 4. If you recognize that, good for you. All right, but I just showed you all the work. If you wanted to work it out, that's fine as well. Let's go to the next one. All right, the slope this time is 4. The change in our y is 2 minus r over the change in our x, which is 2 minus 4. All right, I would recommend writing this. Actually, you know what? No, I wouldn't. But if you wanted to, you could write it 4 over 1 and do cross products again. I'm going to leave it like that and do 2 minus r over -2. Move the -2 over by multiplying both sides by -2. So that's going to be -8 equals 2 minus r. The opposite of r then is going to be -8 minus 2, which is -10. I don't want the opposite of r. I want r, which will be 10. All right, let's do a couple of application examples. So they give us this graph of time on the x-axis in months and the cost of electricity for refrigerator electricity costs in dollars. So what I'm going to do is use the points they gave me to find the slope, which is going to be the change in my y, so 24 minus 12 over the change in my x, 4 minus 2. If you wrote 12 minus 24 over 2 minus 4, that's fine. You get the same slope. This is going to be 12 over 2, which is 6. And it wants us to say what this slope represents. So this is what it represents. For each additional month, the cost of electricity for refrigerators increases by So each month I'm expecting to pay $6 more in my electricity costs for my fridge. Part B, similar idea. Let's find the slope. I've got 20 minus 10, that's the change in my y's, over 50 minus 30, the change in my x's. So that's going to be 10 over 20, which is 1/2. All right, so the slope here means that each day, right, each additional day, I expect the height of this plant to increase by 0.5 centimeters. All right. So if I come in and it's been a whole new day, I expect, if I measure the plant will have grown by 0.5 centimeter. Okay, let's talk a little bit about parallel and perpendicular lines. You need to know that the slopes of two lines that are parallel are the same. So the slopes, if you know two lines are parallel, they have to have the same slope because they never intersect. And then if you know that the slopes of two lines, or you know that the lines are perpendicular, that the slopes are opposite reciprocals. So what that means is we're going to make the sign the opposite. So if it wasn't negative, it becomes a positive. If it wasn't positive, it becomes a negative. And then reciprocal means we're going to take the fraction and we're going to flip it. So if it is not a fraction, you need to write it over 1 and then go and flip that so it's 1 over that number. All right, so we're going to find the slope that is parallel to the pair of points below. Now this should be pretty straightforward, very similar to what we've already done in this video. We're going to find the slope of each of these lines, and because they want parallel lines, we can just say, hey, the slope is going to be the same as what we just found. All right, so the change in y, 0 minus -2, over the change in x, 16 minus 4. 0 minus -2 is really 0 plus 2, which is 2. 16 minus 4 is 12. That reduces to 1/6. So because these are parallel, the slope of the line parallel to this line is going to also be 1/6. Let's go to B. Change in y, 14 minus -20, over change in x, -5 minus 2. 14 minus -20 becomes addition, so that's 34. -5 minus 2 is -7. That is not going to be able to reduce. So what I'm going to do is I'm going to leave it like that. Actually, I'm going to write it as -34/7. And because, again, we want this to be parallel, this is the slope of the line that would be parallel to this line. Okay, let's do the next ones. Same idea, but this time because it says perpendicular, we will have an extra step to say that the slope is going to be the opposite reciprocal of what we find. So this one is 14 minus -19. That's the change in y's. Over 15 minus 13. So 14 plus 19, that is going to be 33. Over 15 minus 13, which is 2. So that's the slope of this line. So the slope of a line perpendicular to this line would be negative, right? Because it was positive. We got to make it the opposite. And then you flip it to be 2 over 33. Let's do part B. We've got 9 minus 9 over -20 minus 17. Now immediately I notice my numerator is 0. And you may have also noticed that both y values are the same. So this is a horizontal line. If you wanted to find a perpendicular line to a horizontal line, it would be a vertical line. And I hope at this point you know that vertical lines have undefined slope. If you didn't get that, that's okay. You can always flip this, right, and make it the opposite. So it become a positive 37 over 0. And you should know in your terms of your math career that you cannot divide by 0. That would be undefined. All right, last 3. Given the equations below, find each of the following: the slope of a line that's parallel and the slope of a line that's perpendicular. Well, these first two, for A and B, are both in slope-intercept form. So hopefully a form you're familiar with, y equals mx plus b, where m is the slope. So because they're both in this form, I can just extract that from this form, right? So this slope is going to be 2/3. So a parallel line would have the same slope. A perpendicular line would have a slope that's opposite and the reciprocal, so -3/2. Same thing in part B. The slope of this line is -5. So a parallel line would have a slope of also -5. But a perpendicular line would not. This has to be opposite, so positive. And then this is what I mentioned when you don't have a denominator. If you wrote this as -5/1, when you do the reciprocal, it would be 1/5. And obviously opposite to make it positive. So this reciprocal is 1/5. So if you're having trouble with that, put it over 1 to help you flip it. All right, this last one is another horizontal line, which has 0 slope. So a parallel line would have a slope of 0, and a perpendicular line would actually be a vertical line, which would have undefined slope. All right, so that's it, guys. Don't forget to try the homework. It's right here. And don't forget to submit it online. Good luck.